This video is brought to you by a cameraman. See, it says cameraman. Not sure what he's wearing here. It looks like glasses. Okay, so we know about theoretical probability. Now we're going to head towards empirical probability. We've already talked about this, that probabilities are fractions, decimals, or numbers, fractions, decimals, or percents between 0 and 1. So this is a nice little number line that also includes words. So 50-50 or 1/2 or 50% is an equally likely to occur or not occur. So that's the line between, hey, here's the likely side of things to happen up to certain, here's the unlikely side down to impossible. Now, when a forecaster says there's a 10% chance of rain today, that means, right, like it's not likely to rain, but it could. There's a really small chance. Beyond that, like 10% it feels like splitting hairs, doesn't it? Okay, so here's some other places where we could do some subjective probabilities that you're not going to do. You're not really going to do calculations. Like, what's the probability you're going to pass this course? I mean, that depends on how much time you have to devote to studying, right? How about the probability you're going to live past the age of 100? Well, that might depend on the genetics that you have, your lifestyle, how much exercise do you get, what kind of food do you eat. That's a difficult one to calculate. Winning $1 million lottery, we can calculate that one pretty clearly. Doing tonight's homework, again, that's going to be your emotional feelings, like how much rest did you get, where you at. That's going to be difficult to calculate directly. So these are kind of, some of these fall into subjective probabilities, where subjective is not really a negative word here. It just means that they're based on evidence. We make an educated guess. In other cases, we can do a thing where we calculate the probability that something will not occur. So we can do, what's the probability of rolling a 2 with 1 die, right? We already did that one. That was our event out of the sample space of 6 things, and we said that was 1 out of 6. That was the probability of rolling a 2. And then we said, well, how many outcomes are in the event of not rolling a 2? Well, if you think about the sample space was 1 through 6, if we define our event as not 2, well, I'll list them. This new event has 5 outcomes. And then we could say, let's define the probability of not rolling a 2. Well, that's 5 out of 6. We would label this not 2. All right, well, what have we done here? We've done this thing called calculating a complement. And what a complement is it's simply all the outcomes that are not in a particular event. So we define one event, and then we say its complement is everything else. So the complement of passing this course is failing the course, or not passing the course. Now, if we think about grades, passing the course could be a 4.0 down to a 2.0. Failing the course is a 1.5 down to a 0.0. So it's not as simple as pass-fail, right? Because this course isn't a pass-fail course. Now, winning $1 million when you buy a lottery ticket, the thing here is not winning $1 million. It turns out that this notion of a complement is often just a tool to calculate, a simpler way to calculate a probability. Sometimes it's easier than a direct calculation. Because what happens is we can do the calculation of the complement is just 1 minus the probability of the event, or vice versa. Now notice we're using the notation E prime to represent complement. So here's a little example. You decide if it was worth it to do it directly or through a complement. So We've got 32 trials on the docket in a county court. 5 are homicide, 12 are drug offenses, 6 are assaults, and 9 are property crimes. If juries are assigned to trials randomly, what's the probability that a given juror won't get a homicide case? Okay, so this won't sounds like a compliment, right? That sounds like a not word. And we're going to do 2 different ways to calculate the probability. First off, let's note this. The number of outcomes in the sample space is the 32 trials. All right? The number of outcomes in our event, which is defined as not homicide, is the sum of all these others. 12 plus 6 plus 9. Let's see. 6 and 9 is 15 plus 12. That's 27 trials. And the number of outcomes that are homicides is 5. We want the probability of not homicide. So the direct calculation there is the one I just did, 27 divided by 32. That's one way. Our author is trying to suggest, wouldn't it be easier to say, well, what's the complement of not homicides? Don't get a homicide. Well, that would be the probability of getting a homicide case. So the probability of a homicide case is 5 out of 32. And if we can use this to calculate the not homicide. So the probability of not homicide, we'll use H, is equal to 1 minus the probability that the jurors were assigned a homicide. Oh boy, you can't see what I'm writing. So that would be equal to 1 minus 5 out of 32, which is the answer we had above, 27 out of 32. So is that easier? I don't know. This is the direct calculation. I had to add together these 3 numbers to get the 27 out of 32. This is the indirect calculation, and I had to just do this arithmetic in my head. Now, I'm going to show you how to do this arithmetic in Desmos if you don't like fractions. So let's check that out. We needed to do 1 minus 5 divided by 32, and it gave us this nasty decimal. If we wanted fractions, we click this little fraction button, and it gives us that 27 out of 32. Now, I think in reality, we probably would prefer the 0.84375, because in my mind, it's often easier to think about a percent conceptually as this roughly 84%. There's an 84% a jury will not be assigned a homicide case.